Hi everyone. We've got a few people out, and today we're doing kind of a new subunit of motion called acceleration. And not that it's overly complicated, but I think it's just best to explain it. So I decided to make a video, just kind of walk you through it. So if you were gone yesterday, unfortunately you missed kind of a fun Hot Wheels lab day where we made tracks and we kind of put them up around the room where we raced Hot Wheels around. I'll try and arrange it for when you come back if you missed it. Maybe you can catch up and do that. But what we did yesterday is just make some data tables, essentially. So I did give that to you yesterday as an assignment. Oh, sorry, I'm looking for the wrong thing here. There we are. So this is what your assignment yesterday looked like. And obviously it has the instructions here that were for in class. Because you weren't able to do that, so I just gave you the data. It's just like a sampled set of data. The mission yesterday was to just calculate the speed of each part here. Now notice that the three different questions actually ask for different speeds from different points. Number one said, calculate the speed using the total time and total distance. So all you use is just this kind of D point, which was the finish line. So if I was to do that, distance equals speed divided by time. No, it doesn't. Sorry. Speed equals distance divided by time is what I meant to say. And that formula is right here. Speed equals distance divided by time. So if you just work that out, let's do the first one together. Speed equals 6 meters divided by 1.43. And if you plug that into your calculator, then you should get, I'll do that right now, 6 divided by 1.43, I should say 1.43 seconds, is 4.195. I'm going to round that to 20 meters per second. So that's the first one done for you. Please remember to use units. What you'll do for trial 2, you'll just do the second table here. Trial 3, you'll do the third table. Okay, number 2, if you look at it, it says calculate the speed from point B to point C. So that's going from B to C here on the table. So let's do the first one together. Remember, speed equals distance divided by time. I'll try and get it the right way around this time. Speed equals, now my distance is actually going from 2 to 4 meters. So 4 minus 2 is just 2 meters divided by, and you've got to find out the time it took to get from here to here. So let's actually look at that. If I use my calculator again, I'm going to take 0.98 seconds and I'm going to subtract 0.27 seconds. So it's going to be 0.71 seconds. Speed equals, so I'll go ahead and calculate that, 2 meters divided by 0.71 seconds. My speed at that point was 2.816. I'm going to round that to 2.82 meters per second. The third one is point C to D, so you're going to do the same thing. Realize that you move 2 meters, and then take this number minus this number. That's going to be how long it took to get there. So that's going to be its speed. Okay, if you need to pause the video at this point and go back and do that, you can. And then we're actually going to move on to the next section. So again, if you want to pause it right now, go ahead and pause, and then come back when you're ready to do the next section. But I'm going to go ahead and show you what to do here. Now, graphing on computer is really tough. So if at this point you can print it out, that would be awesome to go ahead and do this. Otherwise, just kind of visualize what your graph would look like. take the data from the table and just kind of visualize, okay, where would I put it on here? If I have time in seconds on the bottom, time in seconds, I would go up to 2 seconds on the bottom. It went pretty fast, the car racing from beginning to end. So you've got 10 blocks here. I would do 0.2 seconds for every block. So we go 0, 0.2, 0.4, 0.6, 0.8, 1, and so on. On the side of our data, actually everyone's data, the maximum distance was 6. So I would even skip and do 1 block is 1 meter, but you can always skip and go 0, 2, 4, 6, because that's the only data we have is at 2, 4, and 6. So again, just kind of, if you can print it off and make time distance graphs just using these tables, go ahead and do so. If not, try and visualize what that graph would look like. Again, if you need to pause the video to go ahead and do that, great. I'm going to go ahead and move on. Discuss the similarities and differences between your graphs. Okay, if you do this, what you should see, and actually I'll encourage you to connect the dots on this one. If you do print it out and do a graph. If you connect the dots, what you should see is actually a graph that looks kind of like this. But what probably happens is the graph goes the other way, so it kind of rises steeply at the beginning and then levels out towards the end. The reason behind this is we dropped the cars from a ramp. So initially it just goes very, very fast down the ramp. Then if you can visualize it, as it comes off the ramp, it's leveled out and went slower. So our speed changed over time. And that's what we're looking at today. We are looking at acceleration. Acceleration is a change in motion. So at this point, let's go ahead and look at what that means. So part 3 is acceleration that we're looking at today. Acceleration is just whenever an object speeds up, slows down, or changes direction. So the warm-up question today was, when do you feel motion in a car? Actually, if you're just sitting there and you're going at a constant speed, you probably don't even feel like anything's in motion. I mean, you can look outside and see you're in motion, but you don't feel it. The time you feel it is when you speed up, when you slow down, so when someone hits the brakes, or when you turn. You turn and all of a sudden the car goes one way and you kind of go, oh. You feel that movement. So again, change of speed, direction, or change in speed and direction. Get myself out of the way. There we go. Acceleration can be positive, which means you speed up. Negative means you slow down. 0 acceleration means you're not moving. This would look like a straight line on a speed time graph. Okay, here's what you're going to need for number 8. You're going to need to know the formula for acceleration. So please write this down. The acceleration is a change in velocity divided by time. And how you find that is this. Acceleration equals your V final, or your final velocity. In our time trials, we'll use speed as our velocity, so it'll be our final speed minus our initial speed. So minus how fast we were going at the beginning, divided by how long it took us to do that. And acceleration is measured in meters per second, because you're changing speed in meters per second, and we measure it in seconds. So let's take a look at an example first. Number 1, motorcycle's velocity at the top of the hill is 11 meters per second. So it's kind of flying down the hill at 11 meters per second. As it goes down the hill, it's actually going to go faster. So 4 seconds later, it reaches the bottom of the hill with a velocity of 20 meters per second. What is the acceleration of the motorcycle? So we'll set it up. We'll say acceleration equals its final velocity minus its initial velocity divided by the time it took to increase its speed. So in this case, its final velocity was 20 meters per second. That's how fast it was going at the bottom of the hill, minus its initial velocity of 11 meters per second. That's how fast it was going at the top of the hill, divided by the 4 seconds it took to speed up. 20 minus 11 is 9. And again, divide that by the 4 seconds. If you plug that into a calculator, your acceleration is 2.25 meters per second. It seems confusing, but if you work through it a couple of times, I think you will get it. So let's go back and we'll do one together. So what we're going to do is calculate the acceleration of the 3 trials. And once you've got your speed from the trials, we're just going to do from beginning to the end. So your initial speed would be 0, and then your final speed. So if your final speed on trial 1 is 1.2 meters per second, then I'm going to use this formula, which, excuse me, clicked the wrong one. I'm going to use this formula. So your final velocity minus your initial velocity. My initial velocity was 0 meters per second. And then I'm just going to do this. I'm going to draw a line underneath. It's up to you if you want to do it a different way. That's fine. This is just the way that I think is worth doing it. There you go. Divided by how long it took to do that. Well, the time it took to move from the beginning to the end was 1.43 seconds. So that's what I'm going to use. 1.43 seconds. Okay, let's go ahead and work that out. This first calculation is easy. It's just 1.2 meters per second. At this point, actually, I'm going to just do this. Divided by 1.43 seconds equals, and if you take that, plug that into your calculator, 1.2 divided by 1.43 equals 0.839, so I'm going to round that to 84 meters per second per second. So that's just telling us, okay, how much are we increasing our speed per second? Well, 0.84 meters per second. That's how we are increasing our speed. Okay, so I've done a few for you there. Go ahead and finish the last 2 here. And there is a lot, so feel free to kind of go back, rewatch parts of the video if you need to. The slides will be online. And this was in yesterday's, because we started the Hot Wheels yesterday. So take a look back whenever you are ready to tackle it yourself. Let me know if you have any questions.